Hey, good morning, and welcome to today's seminar featuring Astrodyne TDI. During the training session, Glenn, I will be discussing power challenges and finding the right solution for your next project. Everyone is muted, so feel free to type any questions you may have in the chat for this Teams meeting. And Jim will be monitoring the questions and will address those questions at the end of the presentation. We are recording the seminar, and I'll send out a link to the recording and the slide deck to everyone that's attending in the next few days. But be sure to stick around until the end because we do have a chance for you to win $100 by participating in the trivia contest sponsored by Astrodyne. So we'll go ahead and get started. I'll turn it over to Glenn and Jim.
Thanks, Robin. Good day, all. Thanks for joining us today. My name is Glenn Eswine. I'm Director of Product Marketing for Astrodyne TDI. I have with me today Jim Sean, who is Associate, also a Director of Marketing at Astrodyne. My area of focus is generally low power, non-medical stuff, and Jim focuses on medical stuff. So we have both of those types of solutions for you. And what we want to talk about today are just some high-level discussions about solving your power challenges in your designs. So what are the primary considerations when selecting a power supply? I'm sure when you're going through your design activities, you're like, hey, I need this voltage, and I need this kind of power, and it has to fit in the space that I have available. And I need to cost less than a certain dollar value. All those things are generally the types of questions that we get as the first line of questions from our customers. You'd be surprised how often somebody leaves out one of these critical areas in their request. But generally, these are the kinds of questions that we get. And we go, yep, that's great. But what other things are you thinking about that are important for your design? And believe us, there are many. So I want to take a few minutes to talk about some of those things that maybe you don't think about a priori when you're thinking about a power supply for your solution. So, for example, you have to consider what is the source power that's available, right? So a power supply is really a power converter. It doesn't generate its own power. It gets power from somewhere and converts it to a type of power signal that you can use to power your particular application. So as an example, an AC to DC converter, right? And what's your AC source for that AC to DC converter? Is it, a standard wall plug that provides 120 volts in the US or 230 volts in Europe? And does it have a 50 or 60 hertz frequency source? Or is it maybe a DC source operating on an aircraft that's some higher voltage and maybe some higher frequency, like a lot of aircraft applications operate at 400 hertz. So those are important things to know, not just what the output needs to be, but what source are you providing to get that output. You also want to look at, is it a nice clean source or is it kind of noisy source? In different parts of the world, the electric grid is not so great. And so maybe you have other things that you need to consider regarding that. The next thing you want to think about is what kind of cooling method is needed or that you're providing for the power supply. So maybe if you're in a benign environment and you're operating at room temperature, maybe a simple free air convection cooling method is fine. We tend to rate our power supplies in that way in many cases. And maybe it's not a big deal, but maybe you're in a constricted space and you need to provide some forced air to make sure that the power supply doesn't overheat, right? Because the power supply isn't 100% efficient. It's generating some amount of heat on top of whatever ambient air temperature you're operating in. So you need to be looking at, are you cooling the thing, the power supply properly? And, that's important for things like reliability. Depending on the situation, you may have to get into some more exotic types of cooling methods. For example, you may need to conduction cool the supply. So you may have to draw the heat out through a heat plate. And that requires a special design on the power supply to be able to draw the heat out that way. On the high power side of the Astrodyne business, they do even liquid cooling, where they've got cooling pipes running throughout the power supply, and they run liquid through those pipes to help exchange the heat more quickly out of the power supply area. Another thing you might want to think about are, do you need sort of a basic dumb power supply that when you're supplying the source power, it's supplying its output? Or do you need to be able to control it in some way? Do you want to adjust the output voltage sort of real time? Do you need to turn the power supply on and off? Are there monitoring things that you want in the power supply, monitoring features? And if so, what's the interface for that communication to the power supply? Is there a particular standard that you need to use? Is there a response time that you need from that communication? Is there a response time you need from the power supply if you're turning it on and off? Do you need the power to be available within 100 milliseconds after you turn on the supply, or just within a couple of minutes? Another aspect is reliability. So there are a lot of power supply suppliers in the market space. Not all are created equal. Some are kind of really inexpensive, cheap, and may not have the kind of lifetime or reliability that you need for your application. Maybe you're not so concerned about that, and that's okay too. But those are things that you need to consider. So how long is the supply going to operate on average before it sees a failure? And generally all electromechanical equipment will fail at some point. Question is, how long can you expect it to operate before it fails? And that you may have application which is very sensitive to failures. It may be a remote location application that it's hard to get repair people out to, and you don't want anything to fail ever. Those designs tend to be more expensive and more complicated, but maybe it's what you need. When we do designs here, we look at design margin against the customer's lifetime operating requirements. You're also going to want to look at, you want to give us, as the power supply designer, background information about your application, right? So what are the type of operating temperatures that the power supply is going to be in? Is it going to be exposed to electromagnetic surges and types of interference? What type of electromagnetic interference can your application tolerate from the power supply? Are there any hazards or contaminants in the environment that are going to affect the power supply? Like, is there an excessive amount of dust? Or is there a potential for moisture exposure? And is there any sort of mechanical vibration or shock that the power supply is going to experience? These are all things that we, as the power supply designer at Astrodyne, need to know to offer you a solution which is going to meet your application needs. And of course, do you have any specific regulatory standards? And it's very likely that you do. For example, most applications require some sort of third-party safety certification from either Underwriter Laboratories or TUV or some other third-party lab, just to prove that the product is safe for operating. And they usually do testing and manage that, address that safety against a specific standard. So there are standards in the US, there are standards in Europe, there are international standards that both of those regions draw from. And in addition, other countries have their own specific requirements. Usually they're based on one set of standards or another. Sometimes they have additional requirements. And so, for example, if you want to operate a product in Japan, you really need to get a specific safety certification from a Japanese agency. And just getting a universal, there is no universal safety standard for countries around the world. There are also electromagnetic compatibility requirements in the US, in Europe, and other countries. Again, they mostly draw on standards. The FCC has a set of requirements for the US. The European Union has standards that they address for their requirements there. And then in addition to safety and EMC, which are sort of general regulatory requirements, there may be specific regulatory requirements for your application. So a very good example is SEMI F47. If you're operating a semiconductor manufacturing equipment application. SEMI F47 is a power droop or power loss requirement that power supplies need to meet. You may need that for your application. There are also military types of standards that are requested depending on the application. DO 160 is an airborne set of standards, and there is a whole slew of mil standard standards out there that may be required for one application or another. So now you see that it's not as simple as saying, hey, I need a 12 volt, 30 watt power supply. There's a lot more to it. And we're going to be asking you all those questions when you come to us looking for a power supply. So at Astrodyne, we have great experience in making power supplies. We've been doing it for over 60 years. We have global engineering and design teams. We have teams where our headquarters is in New Jersey. We have design and manufacturing teams there. We also have design and manufacturing teams in Asia. Specifically, we have a couple of locations in China. We have back in the US a West Coast facility, which is predominantly application support, applications and sales support, but they also have design capability there as well. And we have local technical support in Europe with applications engineers, as well as applications engineers in the US. So we are well positioned to support you wherever you are, almost, at least in the US, Europe, and parts of Asia. Maybe if you're in the middle of Africa, we might not have great resources there to support you, but, in this day and age, online is great. We're responsive by email. We have links on our website. So we can support you around the world. We are leaders in technology in our focus markets. So for the low power area where I work, predominantly we address industrial and medical applications, and they're both kind of broad. I think industrial is very broad, and we kind of consider everything industrial that isn't a medical patient contact application. One exception might be consumer type products. We usually don't focus on those because they tend to be super cost sensitive and not too concerned about quality, where we focus more on quality and solving tough problems. In the medical space, we're a world leader in low leakage solutions, including BF and CF leakage, CF being the most stringent patient contact type of application. We know how to design for extreme operating temperatures. So more and more, we're getting requests to operate down to minus 40 degrees C and up to 85, 100, even 105 degrees C. We know how to do thermal designs for power supplies that can tolerate those operating temperatures and be reliable and long lifetime in those cases. We also have an in-depth understanding of the regulatory requirements for different applications. There are different standards for medical, there's different standards for industrial, there's different standards for instrumentation and lab type products. We understand all of that. And if we haven't done it before, pretty good at learning it. So we've gotten requests recently for, there are different standards for hazardous materials locations. We've got requests to support volatile atmosphere applications. We're working right now on a fire protection opportunity that requires a different UL standard. So that's an area that we have expertise. We know how those standards work. We can read through new standards and understand how they're going to affect the power supply and really determine what's necessary for the design. And all this, we leverage our core competencies, which just a short list of them include high efficiency designs. So efficiency is becoming more and more of interest lately to be, for a green world. We want to make sure we're not wasting energy, and we want our designs to be highly efficient. And that also helps with managing thermal performance. We focus on low leakage, as I mentioned before. We focus on high reliability. So we want to provide solutions that are going to last you a long time. They're going to perform well in your application, and they're going to serve you well. And we do customization. And this is something that not all of our competitors will do, but we will very frequently, as long as the business case is reasonable, do modifications to our standard product. Things can be very simple, like changing an output voltage a little bit or changing a connector, to very complex, doing full custom designs for a very unique sort of application. We do all of that at Astrodyne.
Hey, Glenn, so I'm going to just jump. Well, actually, you're going to show it right here. So, a question from Brooks is just, is there a limit to the range of power level ratings that we can address? So the short answer is, we pretty much say we do anything from 5 watts and up. And then here you can kind of see some of the power levels on the low power side, and then on the high power side, it's mainly 1 kilowatt and up, and it's stackable to thousands of watts.
Yeah, so Astrodyne as a whole can support just about any power level. The low power solutions we tend to classify as below 1 kilowatt, but in some cases we do more. For example, we have products with solutions that are designed so you can parallel them and get 2 times, 3 times, 6 times the power. Yeah, so good segue, Jim. Here's a quick overview of the types of products that we offer. So you can see sort of on the left that we offer a lot of different form factors. We offer open frame solutions, enclosed solutions, encapsulated solutions, PCB or board mount solutions, the normal sort of a chassis mount solution. We also offer U-channel, which is kind of halfway between an enclosed and an open frame power supply. So it provides some level of fixturing to put in your system. And you can see for all those different applications, kind of the power ranges that we support on the low power side of the business. It's typically 5 watts to 550 watts, but again, it can be a little higher with parallels, paralleling multiple supplies together. Our typical output voltage ranges go from as low as 3.3 volts to up to about 56 volts. When you get above 56 volts, actually, I think 60 volts is kind of the point at which you're moving into a high voltage area. So certifications are different, designs have to take in other things into consideration. So we don't often go above that 56 volt output, but we have for certain custom designs go higher. So we have outputs that are 180, 250 volts. Some are variable outputs that can go up pretty high. So we have the design expertise to do whatever you need. It becomes a matter of what is the strategic value to us? What is the benefit to the customer? What is the business case? How much is it going to cost? Those are all discussions that we'll have in an engagement with the customer. Our products typically are certified for either medical or general ITE safety certifications, or both. Most cases we're both. Some cases it's one or the other. It depends on the product series. We do have a lot of legacy products where they're very separate. Most of our newer designs we're getting both certifications on. We offer solutions for both Class 1 and Class 2 AC input. So that's whether or not it has that third AC input prong for the protective earth ground. We talked about BF and CF leakage options. 2-MOP is a medical term referring to a method of patient protection. And so 2 means that there are 2 methods of patient protection. It's an additional safety feature, and it's something that a lot of the medical applications require. Class B EMC. So there's Class A and Class B EMC. There's also Class E, but that's typically only for lighting applications. Class B is the more stringent, mostly used in environments that are indoor or where there's sensitive electromagnetic equipment operating, such as like a Wi-Fi router, right? So if you're operating in your home next to a Wi-Fi router, you want to have lower emissions, be less interfering with those sorts of applications. We talked about the different types of form factors that we offer. A lot of things that we're doing more recently are high temperature or wide operating temperature designs, more ruggedized designs for applications that require those types of things. Also, we can do different types of cooling methods. Kind of talked about it a little before. The most common is convection cooling or forced air cooling, but we also offer conduction cooling solutions and even up to liquid cooling solutions, but those tend to be for the much higher power applications. In addition to sort of your regular AC to DC embedded solutions, we offer external adapter solutions from as low as 10 watts to up to 400 watts. We offer DC to DC converters as well. Those range from 1 watt up to 300 watts, and some are external adapters, some are embedded, some are PCB mount, just kind of a variety there as well. We also have experience in offering battery charging systems, and in at least one case, we offer a lithium-ion battery pack that goes with that charging solution. So we pretty much run the gamut on power solutions. My mantra is kind of like, we can do it, whatever you need. It's just a matter of what it takes to do. But we have the know-how and experience to do just about anything. This is just a highlight of some of our most recent standard products. And you can see that what we've been doing is sort of running across the power range. We've been refreshing our product portfolio, updating to newest designs, newest components, newest certifications. So up on the left, on the top, you can see we have a 15 and 30 watt family. Those are PC mount or encapsulated solutions. Then we move into this little higher power, which are either open frame or enclosed, going all the way up to our 550 watt solution, also open frame or enclosed. And this is the one that has special features that makes it very easy to parallel operate multiple units. And we've tested up to 6 units in parallel for about 3 kilowatts of output power, and it maintains load balancing very well. So that's a potential modular-like, sort of like a building block solution if you have more than 550 watts of power that you need. On the external adapters, we've introduced a 30 watt wall mount adapter with interchangeable plugs for international sockets, a 36 watt adapter platform, 125 watt. Our newest that's not on the page yet is a 400 watt external adapter platform. That one's a little different because that one has an embedded cooling fan. So it's not really a, kind of like a semi-sealed plastic enclosure. It's vented. But we have been seeing more interest lately in external adapters that go 200, 300, 400 watts. For all these products, we typically will meet 3rd edition medical safety standards, 4th edition medical electromagnetic compatibility standards, 2MOP for medical BF leakage, and in cases for some of the platforms, we also offer CF leakage solutions. Everything we're designing today has what's called a universal AC input. So generally it operates from 90 to 264 volts AC, which will, support 95 to 98% of the applications around the world. Some applications require a little lower. And in those cases, like some like indoor medical applications, you might need to go down to 80 or 85 volts AC input. We can support that. All of our designs are for higher efficiency. The external adapters all meet level 6 efficiency, which is the current standard requirement in the United States. And that is the most stringent in the world right now. Europe is a close second in their efficiency requirements for external adapters. Embedded products don't really have a regulatory efficiency requirement, but of course, efficiency is important for thermal considerations and power consumption. So all of our designs are, being designed to at least be close to level 6 efficiency, even for the embedded products.
So Glenn,
yep.
Sorry, it's a good segue here. There's a question, how quickly do we adopt new versions of standards? So, the answer there is, yeah, we try to stay ahead of the curve, obviously, because waiting until the deadline usually makes it somewhat chaotic. Yes, I mean, historically, as new standards are coming about, we're usually, it's like a 2-year process before you hear about it to where the deadline usually, comes about. And like I said, we historically try to stay ahead of that curve. So therefore, there's less confusion and chaos later on down the road.
Yep, and that's a very good point. So the very last bullet on the bottom right there is the 62368 certification. That is the most recent non-medical safety standard for power supplies and other electronic equipment. That was introduced a number of years ago, but 2 years ago, the European Union stopped supporting the older standard and now requires the 62368 standard for all new products. Okay, and then in addition to standard products, as I mentioned before, we do modifications and customization. And I'll just quickly say here are a few examples of customization that we've done recently. Bottom left is kind of a really big program, which was the battery charger and lithium-ion battery pack for this medical cart. This is a program that's near and dear to Jim's heart. He loves this one to death because he's been working on it for at least 5 years. We've been in production for a while now, and the customer is always looking for improvements. In the top left, here's an example where we had an AC to DC converter module that needed to be put into a ruggedized outdoor communication box. And the trick here was the thermal design. The customer had originally designed in a off-the-shelf 500-watt power supply for their 300-watt application, thinking it would be fine, and it just kept dying after like an hour or two. And they came to us and said, you know, what are we doing wrong? We explained to them about how the thermal design works, the heat that's generated by the power supply, how it's burning itself out. We offered them a better high temperature solution, designed it into a full power module for them that they could use in their solution. In the top right, a couple examples of some pretty oddball things. One is a power over Ethernet power supply, where multiple output voltages and output powers are needed, and it needs to be controlled remotely over an Ethernet interface. And we were able to do all that with our technology. We had a customer who was operating a winch straight off of a motor control, and their customers were burning out the winch, and they said, hey, we need a way to sort of safety protect our winch. We designed a solution for them there. And then in the bottom right, we had a customer who provides a real nice heavy duty power torquing tool to like tighten nuts onto like truck tires or in construction equipment. And their tool operated off of battery packs, which are great for mobility, but not so great for longevity, meaning like, you know, they couldn't operate the tool all day without having to change out battery packs multiple times. Then they had to recharge the battery packs overnight. So they had customers who were like, can't we just plug this thing into a wall, into an AC outlet? And it turns out that that's pretty complicated because these torquing tools are really heavy duty, and at their peaks, they require 600 watts of output power, even though the average is much lower. But when you're finally tightening that nut onto that bolt, you really need some high torque and some high power. So we were able to design for them a power module that can plug into the wall, and then the DC output feeds through a long cable to the hand tool. And now they can operate those tools as long as they want during the day. Nothing overheats, they don't have to recharge, and they can meet the requirements for the application. So I'm getting short on my time. This is the final slide, and it's a lot, so I'm not going to go through it word by word. But the point is, we know how to design power supplies for just about any application. We know what's required, and we always meet the latest technology and the latest standards to give you, the customer, the solution that you need. So we have a broad portfolio of products that we can draw from, and we can customize off of that portfolio. We offer differentiating features. We can help you with regulatory requirements. We do rapid prototyping of modified products. So in some cases, we can get you a modified product in just a couple of weeks if it's a minor change off of a standard product. We support communication interfaces and other digital interfaces for enabling and monitoring the power supply. We do our own design and our own manufacturing in most cases, in either the US or in our own factory in Asia. We also have partner manufacturers to help with really high volume product. And we can offer value-added design services as part of your engagement with us. Things like mechanical design and system integration, helping you with thermal management, making sure that the power supply is going to work in your system the way you need it to work. And then in addition to all that universally, there are specific requirements for medical applications that we know we need to meet. So for example, our manufacturing factories are certified to ISO 13485, which is a medical specific quality control requirement. Sometimes we have to make stuff just in the US, for example, for some military applications. Some medical customers prefer it be in the US. They feel better if the manufacturing is closer to them and they can come and audit us easily. We meet the latest medical safety and EMC standards, all the different types of applications, BF and CF leakage, class 1 and class 2 protection, 2 MOOP and 2 MOP. We also support class 3 medical device specifications. And maybe Jim, you want to chime in on that last detail.
Yeah, now quickly, I mean, I don't know if anybody here is on this medical, but for class 3, it's usually implantable type devices. So we power the actual artificial heart for 3 companies. We power left ventricle assist devices for a couple companies. So on the medical side, I mean, we do some really serious types of powering of high-end medical devices that are literally keeping people alive.
All right, so I thank everybody for your attention, and I hope this little discussion gives you more to think about power supplies and recognize that sometimes it's a more intricate consideration than you might think, depending on your specific application.
There was one other question too about partnering and things like that. So I guess just quickly to kind of somewhat address that. Yes, I mean, half of our, I guess I'd say about half our business is probably standard, and then the other half is probably mod standard / custom. So it really depends on the customer's needs, what they really need to then determine exactly how we're going to solve that and whether or not a standard is going to fit the bill or if it's going to need to be a mod standard or a full custom. At that point, we then assign custom part numbers. We don't usually assign custom part numbers for standard parts unless we have a customer who is mainly usually on the medical side that is like a level class 3 type FDA type device where they want configuration control. So at that point, we'll then usually give them a custom part number so we can then guarantee that we offer them the highest level of configuration control. We're not changing any parts or processes without notifying them. Other than that, we don't usually assign custom part numbers to people for a standard part. If that makes any sense.
Were there any other questions that you saw, Jim? That
no, that was well, actually. So question was how quickly? Yeah, no, I think that's it. I don't see anything else of interest. I guess I see Robin put a poll up of does anybody have any interest or think they need anything that we can help them with? And I guess there was 2 people that said yes. So obviously we're going to want to know who those 2 people are at some point. I guess there'll be contact information sent out. Either Monica or Robin.
Field sales will follow up with those customers. Mm-hmm.
Perfect.
All right, so who's ready for trivia?
I'm ready.
All right. I'm going to be sharing my screen. And the trivia consists of 5 questions. Please make sure to log into www.kahoot.it. The link is right here at the top, or you can use your phone to scan the QR code. Once you get into the website, you can go ahead and enter the game pin and put your name in the box, and you'll be ready to start playing. So I'm going to give everyone just a couple minutes to log into www.kahoot.it, enter the game pin, and put in your name to participate in the trivia. And again, it's only 5 questions, so it should be quick and easy. I wish everyone good luck, and make sure you participate. And if you use like a nickname or something like that, if you do win, we make sure to put in your full name and email on the chat so that Robin can follow up with you and make sure you get that gift card from Astrodyne TDI.
We should probably let people know, if you've never played one of these Kahoot trivia games before, you get points for every correct answer, but you also get more points the faster you respond.
Yeah, that is correct. So good luck. You have to answer pretty quickly. All the questions were part of the presentation, so I hope you were paying attention. and hopefully you can win that $100 gift card.
Sure, and everybody can participate on this.
Even
Whether
Glenn?
everyone else wants- You know, I know.
I tried doing that once and I got yelled at.
Did you?
I also want to say to make sure to not let your phone go to sleep, just because if it does go to sleep, you might get kicked out of the game. So make sure you're constantly kind of like touching your screen so that you don't get logged out. So I'm gonna go ahead and get started. And the game pin will still appear at the bottom of the screen just in case you haven't logged in yet or having a little bit of trouble. You can also message me if you want me to pause while you log in, but I'll give you a couple seconds and we'll
Hey,
get
Monica, I just wanted to double check. I think at least one of these questions is a multiple answer question, right?
Yeah, that is correct. And it will say it on the screen that there's multiple answers, but I'll make sure to let everyone know when that question comes up too. All right, we're gonna get started. All right, so okay, first trivia question. Which of these is not a primary consideration for selecting a power supply? So which one is not? And this is just one answer that is the correct one. All right, everyone got that one right. We'll see.
All right, good start.
All right, it looks like Jonathan has speedy fingers, so hopefully you can keep answering quickly so you get the most points. Next question. Which of these power ranges are low power solutions for? So low power solutions support, and this was part of one of the slides. It was a range of power ranges. So only 3. Do you want to send a message here, Glenn? There were
Yeah,
3
so yeah, again, the low power side of Astrodyne's business is typically sub 1 kilowatt. And we offer solutions that range from 5 to 550 watts, and it can go higher with parallel operation.
Right, we'll see who answered correctly. Ooh, Robin. All right, next question. True or false? Astrodyne TDI cannot provide modified or custom power supplies. And this is also part of the question, one of the questions. So hopefully everyone will get this one correct. All right. See who answered quickest. Uh-oh, Jonathan is on fire now.
Wow.
Answer streaks in a row. Next question. This is a multi-select, so there's multiple answers. Astrodyne TDI is recognized as a leader in uh-oh. All right, we'll see who got that one correctly. So it was understanding regulatory standards, extreme operating temperatures, and BF and CF leakage. We are recognized as leaders in all of those. Jonathan's still in the lead. Michael is coming for your position though, so.
Oh, Jonathan has a commanding lead going into the last question.
Yeah, did he get the answers from online or something? I mean, that one was a pretty tricky one, all 3. I thought it was only 2. Even I missed that one.
All righty, next question, and this is the final question. Astrodyne TDI AC/DC external adapters are certified for medical applications only. True or false? I feel like there's one person. Oh, okay. So this one was false. We have our products are certified to multiple regulations. And there was a slide on that. So we'll see who is the
So,
winner.
Jonathan, did you say true?
Drum roll.
AV, third place. Robin, second place. And first place, which is very surprising, Jonathan.
Congratulations, Jonathan W.
Congratulations.
Yeah.
That's great.
5 out of 5.
Awesome. Thank you guys
Nice.
for participating.
Oh, thank you all. We appreciate you taking the time to join us. And Glenn and Jim and Monica, thank you for the information. Great presentation. I will be sending out the recording and the slide deck to everyone in a few days. And if you have any more questions or want any more information on this topic, please feel free to reach out to me or to your TMC field sales representative. But hope everyone has a wonderful day. Thank you all.
And Robin, how do we get Jonathan's gift card to him? Will you reach out to him?
Yes, I will.
Okay.
I'll send a message to Jonathan.
Great. Awesome.
All right.
Thank you, everyone.
Congratulations and thank you.
Thank you, everyone.
Guys.